I've chosen a number of names for strange reasons. So, what are your strange reasons?
I think it's I don't know, I like the all vowels thing. I like that it's kind of fun to say. It kind of just like flows out of the mouth. Uiua, right? There's something fun about that. That's about it.
Does it have a meaning?
Not really.
Oh, but you could say it does mean something because it's actually Latin.
Is it?
It's a it's the nominative, accusative, vocative plural of we wum.
And a wee one being what?
That which is alive.
I like that.
Oh, well, that's pretty nice.
I didn't know that.
It lives.
Welcome to another episode of ArrayCast. I'm your host, Connor, and today with us we have a special guest who we will get to introducing in a couple minutes. But before we do that, we're going to go around and do brief introductions from our panelists. We'll start with Bob, then go to Stephen, then go to Adam, and finish with Marshall.
I'm Bob Terrio, and I am a J enthusiast.
I'm Stephen Taylor, enthusiastic about APL and Q.
I'm Adam Brozewski. I do APL.
I'm Marshall Lockbaum. I'm still a Singeli enthusiast, but maybe more relevant for this podcast. I'm the creator of BQN, and in the past, I've been a J programmer and worked at Dialog.
And as mentioned before, my name's Connor. I am a polyglot programmer, research scientist by day, and array enthusiast by night, and by day, actually, I guess. And we have a couple announcements. We have two from Adam and then one from me. So we'll go to Adam first.
Okay, so if you hurry up just as this episode comes out, then you can get a 30% discount on the entrance to LambdaConf, where Aaron Su will be doing some APL. If you don't hurry up so much, then you'll only get 15%, but we will have in the show notes links to both of those reductions in the price. And then there are still a couple of weeks left to the Dialog 23 user meeting. That's the 15th to the 19th of October in Denmark. And what's special now is that all the program is up, so you can see titles and abstracts of everything that's going to be there. Lots of interesting stuff. Have a look. You can still make it.
Awesome. Links in the show notes. And my announcement, if you recall back in 2022, I think it was late August, September, there was a dialogue run meetup in both Toronto and New York, where we had a couple different speakers. There is going to be a 2023 edition of just the New York or just the Toronto version on October 2nd, which I believe is going to be 2 or 3 days after this podcast gets released. So if you are listening to this within 72 hours of its being released, and you happen to be either in or near Toronto, and you are free on Monday night, October 2nd, there will be a meetup. It's taking place downtown Toronto, very easy to get to via transit. And there's going to be, I think, 4 different speakers. This is off the top of my head, so if it's wrong, I apologize. I believe Richard Proctor, who is local, he is going to be speaking, and then both the CTO and CEO of Dialogue Limited, aka Morten Kronberg, and Gita Christensen are going to be speaking, as well as myself. And there's going to be a social afterwards, I think around 8:30ish. So even if you don't want to come for the APL talks, I'm not sure why you wouldn't want to come for that. But you just want to show up to the social, you can also do that. So links will be in a meetup.com link in the show notes. With all of that out of the way, today's guest I am very excited to talk to is Kai Schmidt, who is the creator of, if I'm pronouncing this correctly, the Uiua language, which is spelled Uiua. So I definitely would not have guessed that. And Kai's going to fill us in on his background, but this is I think, array and stack programming language that is implemented, I think, entirely in Rust, which makes it even more interesting because I don't think I'm aware of any array languages that are implemented at any level in Rust. I think most of them are just implemented in C. That I know of. Anyways, I will stop there, throw it over to Kai. I'm not sure if you want to start with sort of giving us a brief background or introduction to yourself, and then we can hop into talking everything about this Uiua language, which looks very, very cool.
Thanks, Connor. Yeah, so my name is Kai. I've spent most of my career in the construction industry doing various making automation tools and things like that. I don't actually use any array languages. in my day to day, or I didn't use really any at all before I started listening to this podcast. I'm actually an avid listener. I've listened to most of the episodes, many more than once. And so a lot of what you guys have talked about here has really inspired a lot of well, for one, it's been a lot of the material I've used to learn about array languages. And it's also helped me make a lot of the decisions because I kind of fell in love with the paradigm. I think I first heard about APL, I think, in college, but I didn't. It wasn't from someone who was into APL. It was just part of like, here's a bunch of languages and here's what they're all like. But later, I think it was a few years ago, I saw a post on Hacker News about this language called BQN. I was like, oh, what's this all about? When you go to it, and I don't know, the editor and I don't know, Marshall's writing and stuff, I was like, whoa, why have I never seen this before? This is so cool. And my first instinct was like, this is such a cool idea, except I don't really like this and this and this. I'll just make my own. That didn't come to anything. That didn't come to anything. That was a while ago. That was a few years ago. So I think once or twice I've tried to make my own. Well, I'm kind of a language enthusiast as well. I like writing like interpreters and stuff. And so finally, when I starting to write Uiua, I had that name that I'd come up with a few years before, but it wasn't even going to be an array language. What I started with was it was definitely a combinator language, though. The idea being that a bunch of combinators would be first class like operators. That you could compose kind of these combinator primitives into like higher order combinators. So you have these basic ones like your hooks and your forks and things, and there'd be ways of simply composing them to take more arguments than that, so that you could do full tacit programming. Your guys' episodes about tacit programming, I think, those are some of my favorite ones, and those are the ones I wanted to, or that's what I wanted to try to shoot for. I really like the idea and the beauty of just having your data just flow through a bunch of functions and not have to worry about variables or scope or any of that. And so that's kind of been the driving design principle behind Uiua. So that's kind of the background of how I got to this.
All right, I've got, 1,000 questions. But should we let, I feel like we should let Marshall have the first question because, he has inspired this whole, I don't know what we call journey in language with BQN. And I guess, well, I'll steal the first question. When you saw the BQN post, was this pre-ArrayCast or was this while ArrayCast had already started?
I don't remember. What I do remember is I started listening to the ArrayCast, I think a few episodes in. And then as I listened to it more, I was like, wait a minute. This Connor guy sounds a lot like that YouTube channel I'm subscribed to, Code Report. It's like, wait a minute. It's got to be the same guy. There's no way.
Yeah. I've realized that sometimes I don't mention often enough that I have a YouTube channel, and I'll be giving a talk at a conference, and like at the 75% mark, I'll show a thumbnail from one of my videos, and then a couple people after will be like, "Oh, I didn't realize that was your YouTube channel. Like you never mentioned it." And I was like, "Oh, like I thought I did. Whoops." Anyways, if there's people listening, I assume they know at some point I mentioned it in the podcast. But anyways, back to Marshall. What's your first question, Marshall?
Well, I have to ask about the name, I guess. So you said you came up with the name before even coming into the array paradigm.
Yeah.
I've chosen a number of names for strange reasons. So what are your strange reasons?
I think it's I like the all vowels thing. I like that it's kind of fun to say. It kind of just like flows out of the mouth. Uiua, right? There's something fun about that. That's about it.
Does it have a meaning?
Not really.
Oh, but you could say it does mean something because it's actually Latin.
Is it?
It's the nominative, accusative, vocative plural of uiuum.
And a uiuum being what?
That which is alive.
So those which are alive?
Those which are alive.
I like that.
Oh, well, that's pretty nice.
I didn't know that.
It lives.
It lives, yeah, something like that. You could like make a free translation to "it lives."
I could talk about actually the kind of the history of like the design iterations I went through and how how I came to think about array programming and tacit programming and things.
Well, so the thing that I'm curious about, which I think probably should wait until we've gone over that stuff, is actually the array model, because I know you started with a flat array model and you went to
Oh, I started even earlier than that with other stuff. I'd love to talk about that.
you're currently on a non-flat array model, which
Yes.
seems to be different from all the others. So that'll be very interesting to hear about.
Yeah, take us back in time to the beginning and tell us the history of how you got to.
Yeah, so it wasn't originally an array language. Like I said, it was a combinator language. As I started like getting more into like the array paradigm, I was like, oh, I could do this. So I started with the easiest thing to implement, which is of course non-multidimensional arrays, kind of I believe that more of the K-type model, where things are still ranked polymorphic, but a multidimensional array is vectors of vectors. And then I was like, I think I could do the whole shape-based flat array thing. And so then I started implementing after reading the thing on the BQN website about the based array model. I was like, oh, I'll try implementing this. And so I did, and it was very complicated. At least I found, because you had to do checks for, okay, is this an array? Is this a scalar? You have to write different cases for different things. And I also found it kind of hard to reason about. And so I simplified it to just a flat array model, like APL 360 style, no nesting, no nothing. What I did have in that model was this idea of fill values. So there's special values for each type. For floats, it's for regular numbers, it's like nan. For characters, it's the null character, etc. And this value would be present in arrays to simulate having like jagged arrays, arrays where like the rows are of different lengths. So for functions like group or partition or just splitting things up, anytime you could have an array where or a matrix or anything that has different lengths, you'd fill in the ends with these fill values. And so while you still have a nice square, rectangular, however many dimensions arrays, you could still have this non-homogeneous length data. And of course, this creates, you waste some memory here, but I kind of liked the simplicity of it. What was not simple was putting the checks everywhere in the interpreter to properly handle those fill values. And it also had the unfortunate side effect of, for a byte array, which I had byte arrays because I wanted to be able to efficiently read in files. For a byte array, it had the unfortunate effect of making the bytes 2 bytes long, because there's no value between 0 and 255 you can use to indicate this is a fill value. And so it ended up being 2 bytes long because you had to have it was basically a union or an enum. And I could have, there might have been a way to do it such that the fill status was stored separately, like a bit mask or something. But I decided I didn't really like how it was working. And so I moved to something, and you talked about how it's not really like, it's kind of different from all of them. And I guess it is kind of, what I settled on is kind of different, but it's most closely related, I think, to Jay's model, where everything's flat. They're not actually boxes that you can put the arrays in. There's only 3 data types. There's numbers, characters, and functions. And so the equivalent of Jay's box is actually just a constant function, a function that just pushes your value to the stack. And so there's a function called constant, which if you say constant 1, it creates this function that returns 1. And then of course there's a call function, which is the equivalent of Jay's, like unbox, or I think for APL is like disclose. And so you have this simplified model, kind of it unifies boxes and functions and things. And I think it's fine. It works. I do want to explore further the idea of simplifying the model further. I do like it's nesting. Being able to have nested arrays seems very necessary inherently in trying to solve problems. I would like to explore ways of making it so it's not actually necessary, just because I like the elegance of the flat arrays. But that's something I'll have to investigate more.
Well, it clearly isn't necessary because, should we say, in APL's heyday, it wasn't possible in mainstream APLs, and that's when people were making money using APL. So
I'm curious then, like, I don't know, how did they, if you wanted to do something like say I wanted to just split a string into the words in the string, and they're all different length, and I want an array of that. How would you do that in a?
So you'd be very clever. You start off by finding the separators, I suppose, right? And then you can compute how long the segments are, and that allows you then to expand with fill elements at the end of each segment, and then you reshape into a fixed column width.
I see. Yeah, so before I actually had something like that, but that has the fill elements, right? Each row gets appended with fill elements, and I do still have. I don't know if you guys have seen it. There's a modifier.
Well, and to be clear, they would just use spaces. They would. So this was not always safe for like if your data had spaces in it. You may not end up with the best code for working around that.
I see.
There's also the issue of the separator, right? What if your data has the separator in it? But I should also say, would you want to split it?
That's what I'm trying to answer. I'm trying to think like, is there a way to not split it? Is there a way I can solve problems I'm trying to solve without having to do things like split it? So like, I don't know, say I wanted the counts of every word in some corpus of text, things like that.
There are all kinds of clever algorithms.
I'm sure.
Yeah, well, for counts, you don't even need to have to be that good. What you do is just take all the indices of the separators and subtract the index of the previous separator from the current one, or well, index of the next separator probably, and that gives you all the lengths. There's a very nice paper that
you're saying you index your array separately and work on the indices.
Well, you find the indices of every separator that's in your big string with everything together. So you say, where's this separator and the next separator and the next separator, and the length of a segment. Well, I think you have to subtract 1 too, but it's just the number of characters in between the two separators. There's a really nice historic paper by Bob Smith that's, I don't remember the title exactly. It's about operations on partitioned arrays, which has for a lot of more complicated stuff, like if you want to sum each segment of an array or something like that, it has a bunch of operations that you can do just purely using flat arrays, where you'll take in just a list of all the data and a Boolean list that has a 1 where each segment starts. And then you can do, there's, reductions, there's scans, all sorts of things. And they all require, slightly different techniques, but there's kind of once you get used to this style, you can kind of think of how you would do it for even something that's not covered in the paper.
Mm-hmm.
Yeah. I think Kai's point though is it's a good one. Like there's a lot of small, leak code-ish interview-esque problems like, given a sentence, separated by spaces, return a sentence where every word in that sentence is reversed. And like in a language like Haskell, you can just go words, which splits it into your, each word in the string. Then you can map reverse, and then you can unwords and like put everything back together. And like you can clearly do something in APL, which is the equivalent of like a scatter or gather, where you figure out, each word and then create the indices that you would, I don't actually, what's the operation with indexing called in APL? In like in NVIDIA programming, that's called
like selection.
Yeah. So like you could technically rebuild up a string with the right indices that are the basically reversed indices of each string, but like implementing that to do that in like an array language without actually just splitting, reversing, and then unsplitting is a lot more complicated. Like you can make it happen, but
well, it'll end up looking pretty short because I think it's you find the word starts and then you take the sum of those and then you do the grade down, and that's it. Those are your indices.
There are all kinds of these old techniques that were found for all kinds of flat things, and yes, maybe it is shorter to. And maybe more, you can call it more elegant to do it the nested way.
No, I don't think it's more elegant.
in Haskell, it's more like it's definitely more elegant.
But the flat way is much more sympathetic to the hardware.
This is true.
Doing it the nested way is terrible from the computer's perspective. It's nothing you can really do to make it good or fast.
But as Marshall always says, I don't believe this, but do we even care in perf? I saw that Uiua has Windows, and I was like, I don't actually know the extent that you have support for the different combinators, as in like, SKI combinatorial logic combinators. But I was thinking, wow, if this is like a stack, BQN with Windows, this is a contender now for like one of my top 5 favorite languages, because famously BQN does not have a Windows function, which is very, very sad.
Wait, are you sure?
Oh, no, wait, sorry.
I think that's where Uiua got its Windows function.
Wait. I misspoke. It doesn't have the NWise reduction.
Yeah, that's true.
You have to do you have to do a reduce over each of the lists created by Windows. Is that the same with Uiua?
Yeah,
Okay,
and
never mind. You're out of the running.
and that's actually in my list of to-dos for optimizations, because currently if you do that, it materializes all the windows.
Yeah, exactly.
And treats it separately. I do want to put like an optimization in the interpreter that says, no, if you see this pattern, do it smarter. I would like to talk about doing combinators though, because in moving to, I forget why I even thought, I could make this a stack-oriented language, but it turns out that with just some very simple stack operations, they can be composed and generalized to most of the combinators you're familiar with. So something as simple as composition is implicit, right? Just putting one function after the other, they're just composed immediately, and it's not just like the Bluebird and Blackbird. It's every level of composition, right? So I forget what the other names for those are, but you know what I'm talking about, Connor. All the birds.
Yeah. So Bluebird is just composing 2 unary functions. Blackbird is composing.
Yeah, and doing both those compositions ends up being the same in a stack language. And something like flip, so flip is one of the functions in Uiua, and it just flips the top 2 things in the stack. But just combining duplicate, which just duplicates the top item and makes a copy of it on top of the stack. Combining duplicate and flip by themselves, these can make the self combinator, the flip combinator. I think both hooks, both left and right hook. You might need a little more to have dyadic hooks.
Yeah, well, at some point you got to like duplicate the top, but then flip below the first element.
Yeah, so there's also the over function, which takes the second item on the stack and makes a copy of it to the top. And so with just those 3, you can make most of them. I have a couple extra things to do more complicated stuff. There's also like roll and unroll, which works with the third. It'll either move the top, roll moves the top item on the stack down 2 places, and unroll takes the third item on the stack and moves to the top. I'm not copying, just moving it.
So that's similar to like the ROT rotate.
Yes, it would be
in like languages like Forth and Joy. Also, too, we should. I'm following along perfectly, partly because I did the language tour, and also partly because I spend all my free time thinking about combinators. But maybe we should rewind a sec, and Kai, you can explain to the listener how does. Or maybe even we can go back a little bit further. Like, how did the stack part? Because you said you don't even really remember how you ended up first seeing BQN, thinking about combinators, but then you ended up with both a stack language and an array language. So maybe if you want to, if there's a story there to tell, or maybe not, you can tell that, and then also explain to the listener how does function assignment and like applying functions work if folks aren't. Because like in order to understand how you get implicitly for free like the B and the B1 combinator, I think you need to understand how functions work in a stack language like Uiua.
Yeah, so I think I was aware of stack languages much before I was aware of array languages. So yeah, in a stack-oriented language, every function manipulates a global stack of values, and in general, you pop your arguments off the stack, do some operation on them, and then push the results back onto the stack. And so this is why you get composition for free. So if you do something like, if I wanted to find the negative, take the square root of a number and negate it, I would just say, okay, square root function, negate function, that's it. And because each of those pops its inputs and pushes its outputs back to the stack, it just composes naturally. And so this is really nice for tacit programming, because and a lot of the times you don't have to name your variables and things. It does get complicated when you need to refer to more than say 2 arguments. notoriously it can get very complicated with juggling lots of values on the stack. And I've tried to come up with ways to mitigate how weird that gets. But this is kind of an old paradigm. It's very simple to write a compiler and an interpreter for because the computer does have a stack in it, kind of. And so it's actually a very old paradigm as far as I understand, with the original languages being some things like Forth. There's more modern ones like Factor, which does have like variable assignment and things like that. Yeah, but that's the idea. And so it's already a pretty terse paradigm. And so combining that with the array paradigm, which is also very terse, kind of comes together to make this very, very terse language.
Yeah, and I actually didn't really think about this till now, but I think one of the differences with Uiua compared to array languages is that the arity of all your operations is fixed, correct? Which is
yes,
sounds like a small thing, but it actually leads to interesting things you can do with the language because there's no ambiguity of is this a unary or binary or monadic or dyadic function. It's the arity is fixed.
Yeah, that was when I remember. So when I was first learning, reading the documentation for BQN, I did find, and I found this also reading like APL and J code, is that I did find it kind of hard as a learner, as someone who's like new to the array paradigm, saying like, okay, what is this greater than? Is this, or what is this less than? Is this dyadic or monadic? What does this do?
That'll definitely slow you down, even as an experienced user. It's like you're looking at this sentence and it's like you haven't figured out what the parity of everything or the arity of everything is yet, and then it all snaps into place. But there doesn't have to be that step.
Yeah, you end up having to like bind in your mind each glyph two different meanings that your mind has to then parse through the expression to figure out which one to use in that case. So yes, in Uiua, and actually I don't think you could have what do you call it, ambivalence?
Right.
I don't think you could have ambivalence in a concatenative language. Like concatenative being another word for kind of the way that you write stack-oriented code, because there would be no way to tell what its valence should be if it should take one or two arguments, because everything is just the function. It always, in most stack languages, you write the functions after their arguments. In Uiua, you write them before. So if you wanted to add 1 and 2, you write plus 1, 2. So what ends up happening is that for every built-in function you need, for everything you want a glyph for, you need two different, what would be one symbol in APL or J or BQN, ends up being two symbols. And so, I don't know, something like, I know in APL and BQN, you've got one glyph that represents both the concept of reversing an array and also rotating it by some amount. And so in Uiua, that's two different glyphs, reverse and rotate. The other thing that makes it different to write is there's no special keyboard bindings basically to write the glyphs. You don't do some escape code and then type a character on your keyboard and that makes the glyph. You type the name of it, or like the prefix of the name of it, and then the formatter turns that word into the glyph. And so this makes it easier to write without any special support. And it also lets you, by just learning the name of something, you can write it.
Yeah, it's a novel. Like, I don't think there's any, I mean, there's very similar things in the RIDE APL editor where you, with some kind of backtick, you get the conversion, but there's always something extra. I don't know of any of the languages or an editor that you just type it and then when you hit run, it Unicode-ifies your code.
How does that work? How does it disambiguate between user-defined things and built-in names?
There are compromises that come with this approach. So the parser is a context-free grammar. Well, I don't know about grammar. It's a context-free parser. There's no semantic analysis done.
The grammar is just like sequence of terms, right?
For the most part. We can get into how like modifiers and stuff work, which is like the one precedence rule that exists. But yes, it is mostly just this term, then this term, then this term. But disambiguating that from user-defined things, the answer is that if your user-defined term has the same name as a built-in one, it gets parsed, it gets lexed as the built-in token. And so you must capitalize your username.
So you use capitalization as a disambiguator,
Yes.
But names are not otherwise case sensitive, or what?
Names are not case sensitive.
Okay, so the first letter, kind of like what BQN does, but using that for something entirely different.
Any letter, actually. can capitalize any
If you
letter.
capitalize any letter, then it's your name. If it's all lowercase, it's built in.
Yes. Although you can, if you like, and maybe this is something that needs to get changed for the once I start caring about backwards compatibility, which I don't yet. Eventually, it might have to be the case because currently, all lowercase name, if it doesn't get recognized as a glyph or as the name of a built-in function, will be interpreted as just a regular identifier. That does create barriers then for backwards compatibility if I were to add more built-in functions, of course, because what was originally identifier might become a different kind of token.
That's the same answer as basically the same thing as the answer to people, why can't we just allow people to assign to glyphs in these languages? Because then it becomes impossible to be backwards compatible and add things, yeah.
Well, I didn't think about that because you don't just have to do names. You can identifiers can also be single non-ASCII glyphs. So if you just want to make up your own glyphs and make them functions, you can. Maybe that's not a good idea.
Wait, so accented characters are symbols?
Currently, yes, they are. Actually, no, I take that back. It has anything that's non-alphabetic.
Oh, okay, that's different than ASCII.
Yes.
So it actually does like a Unicode lookup.
Yes. Rust has built-in.
Yeah.
So the interpreter is implemented in Rust. So Rust has stuff for that.
Well, so can I get one thing clarified? So you can store your source code using the ASCII names. Is that correct?
Oh yeah. So naming functions and constants and things.
No. I mean, you're saying there would be a problem of compatibility if you were to introduce some new built-in and somebody had used a lowercase name, but that sounds like this translation from ASCII names to the symbols happens at runtime and not at some kind of definition time or earlier stage, which means
it does.
That means you can store Uiua code as just ASCII text without any Unicode glyphs at all, right? And then run that.
It's stored it's expecting the input to be in UTF-8. So no, the turning the names, turning identifiers or strings of characters into tokens, turning the ones that look like names of glyphs into those tokens is done in the lexer.
Sure, but that's after writing the code, right?
Yes.
So I could potentially write all my code using just English words and no symbols whatsoever.
Yes, you could. And then when you run the formatter, it'll turn it into that. Yeah, this is not usually a problem as long as you format your code. I don't enforce that you format the code, although it is recommended and the default. You could just write code that's all the names of all your functions are ASCII and just pass the flag that says don't format.
But don't format. It sounds like you're modifying my code. Surely, once I've developed my application, I can run it, and it doesn't change my source code when I run it.
Oh, it changes your source code when you run it unless you tell it not to. It turns.
What if my files are read only or on a CD?
Yeah, details. That doesn't matter. Don't make your code files read only.
I haven't. No, that's a good concern though. I actually haven't thought of that. And I don't know. Whenever I write code, I have control of it, but I haven't considered those cases. So that's good to know.
It makes it very unique in having a programming language that changes your source code when it runs it the first time. And
yeah, I guess I'm very used to using a formatter in whatever language I use.
Yeah.
Which formats
it's becoming the default of all languages. Like it started with Go, and now Rust. Even languages that don't have them built in, almost like I refuse to work for a team that doesn't have because like you just end up in so many arguments over formatting. Like you can get rid of like 90% of like code review arguments by just choosing a formatter. It's like I don't even care what I might disagree with the style, but I just don't want to argue about it. Like I'd rather not argue and be unhappy with the way the code looks than have to argue and try to be happy. Sorry, what did you link there?
I linked to Vigil, which is a leader in this field, I believe. What it does is if your code has errors, it deletes them when it runs. So when the program finally runs successfully, there are no errors in the code.
Well, it does this recursively, we should say, right? So if any source file has an error in it, gets deleted, and then it reruns, and then you do that recursively until no more errors present themselves.
I don't know what it does if your source is read only. Never considered
So
that.
yeah, I wanted to go back to, because we kind of went on a little mini history of how the stack part got added to the array part of your language, and so hopefully now the listener, if they rewind when we were talking about the B and the B1, which correspond to the bluebird and the blackbird, I think those are pretty easy to grok your head, and so also, just for the listener, the way that, at least that I understand that functions work, is that if you can just assign a sequence of functions to a function, and because there's no data or arguments there, that's going to just basically be like a mini stack. So if you assign 2 unary functions to a function, that is implicitly the B1 combinator, because it'll...
Yeah, so what it does is it takes you whatever you say, I don't know, if I say F and then left arrow and then a bunch of characters, it looks at those characters and it does some analysis and it says, okay, how many in aggregate, how many values is this going to pop from the stack and how many is it going to push? And if it pops any more than 0, it gets bound as a function. If it pops 0, then it gets bound as a constant and is immediately evaluated. So if I say X arrow 1, then X is 1. But if I say X arrow minus or negate plus, it's a function that adds 2 numbers together and then negates the result.
Right. Because the arity of plus is 2 and the arity of negate is 1. And then that is an example of an implicit B1 combinator where you're composing the blackbird. You're composing a binary and then a unary after that. So what I can't... that I'm not certain how I would do is, you mentioned that you can do things like the left hook or back hook, or I guess there in J it's called hook, and then I introduced the back hook, which correspond to the S combinators. And
that's the programming language.
Yes, the Marshall's first language, where he was exploring combinators. So that involves a binary operation, a unary operation, and then my guess is you're going to be duplicating, so you're going to be using your...
No, for the left, you're talking about the left hook?
Left hook or what?
Left hook's the simpler case, actually. So left hook in Uiua looks exactly the same as composition. So for example, if I wanted to, I don't know, what's a good left hook example?
Palindrome. So
yeah, palindrome. Perfect.
Well, so it depends on how many arguments you're taking, right? So you're talking about the left hook that takes 2 arguments, right? So it doesn't duplicate one of them.
No. So
no, sorry. No, you're right. The left hook would usually involve a duplicate.
I'm talking about the S combinator where the composition returns you a unary function. So you're given a binary, a unary, and it applies the unary to your argument, and then takes a copy of your argument as well and passes those two to the binary function. So in the palindrome case, your binary function is match.
Yes.
Or as they call it in APL, or like in Haskell or something, you'd have to, you'd compose that, but it's checking what the equality of 2 strings. Your unary function is reverse, and then you compose that somehow so you get that pattern. So I guess, can you walk us through both the hook, which is the S combinator, and then the back hook, which they both do the same thing, but it's applying the unary operation to either the first or the second argument?
Yeah, so the left hook is the simpler example. So in the case of, say, palindrome, there's three functions you use. You'd use duplicate, reverse, and match. And so you take your value and you use duplicate. So now you've got 2 of them. Then you do reverse, which reverses the top one. Then you do match, which checks if they match. That's it. So it would be spelled match, reverse, duplicate, since the code runs right to left.
So interesting. So in this, I'm visualizing this as like, so how did you spell it? It's
match, reverse, duplicate, and then code runs right to left.
And then, so say you pass the value, taco cat, and then you duplicate that. So then you end up with
taco cat on the stack.
Taco cat. And then the top one.
Maybe you want to use an argument that's not a palindrome.
Yeah. So, okay, we'll just use cat. So you end up with cat. And so visually, I'm in my head, I'm spelling this equal match cat. And then the top value, is that like the value on the left? Technically, it's not.
Well, you can think of it in whatever direction you want, right?
Yeah, left and right kind of break down.
Yeah, that's true. So really, you should just separate your stack of functions and your stack of arguments, or is that not a good way to think about
function,
it?
No. So the code runs just always right to left, right? So if you see the duplicate first, it takes your cat, and now you've got two strings on top, cat and cat. And then the next function, reading right to left, is reverse. And so one of those gets reversed. So you've on the top of the stack, you've got tac, and then under that, you've got cat. And then finally, reading right to left, you see the match function. And the match function pop both of those off. It says, are these the same? No, they're not. And so it pushes your zero or your false back onto the stack.
Interesting. Yeah, I'm trying to visualize like when you have a sequence or a stack of, at the top of your stack is multiple arrays. And then you have a function of arity that is less than that number of arrays. Which array is that applying to? And
it's always the top.
It's always the top one. So technically you could be calling a function that is, the fourth thing in your stack, but it's applying to the top array. So it's kind of skipping and ignoring.
No, sorry. The functions in general, or in most cases, the functions themselves don't go on the stack. The functions are in the code and they operate on the stack. You can put functions on the stack. Functions are, after all, just arrays, but they're also executed. But in general, unless you're doing like a modifier or something, they don't actually go on the stack.
Interesting. Okay, so that makes sense. And then in the backhook example,
yeah, that came up actually when Marshall was looking at it. Somebody was asking about how to do the matrix multiplication. And in the matrix multiplication, basically, you have to, before you multiply, you have to transpose the second argument, right? And so this ends up being, is that what you mean by a backhook, like a right hook?
A backhook being instead of...
It sounds like it to me. So your transpose is the monadic part of that backwards hook.
Yes.
And it's weird because I is left to right, so its hook and back hook are going to be swapped around.
All right, so but yeah, for the right hook, basically, I think the easiest way is to just do two flips. So you do flip and then your monadic function, and then another flip to put it back down, and then your dyadic function.
Although, so if it's a one argument hook, you start out with a duplicate. Yes. You don't need a flip after that. So it's flip, then transpose maybe. Or duplicate, transpose, then flip, and then your two argument function.
Yes. So it ends up being that the only difference between, say, your monadic and dyadic hooks is going to be whether you have a duplicate at the end or at the beginning.
Okay. Hopefully the listener's following along. This makes sense. So the final question at the end of this combinator rabbit hole is, are you able to code a higher order function that saves this pattern? Having to spell either a couple flips or a duplicate is definitely going to be less ergonomic than the single glyph that BQN has for those things. So could you spell a function that as arguments takes functions?
Yeah, the syntax for modifiers. So in APL, these are operators. In J, they're adverbs or conjunctions. I think BQN also calls them modifiers. I think that's where I took the name from.
Well, J actually calls them collectively modifiers, but that's pretty rarely used over adverbs and conjunctions.
You missed the opportunity, Kai, to new language, new word for it, because we
new name. Yeah, Marshall, correct me if I'm wrong, but in BQN, functions, one modifiers and two modifiers are all different types.
Yes.
Yeah. So in Uiua, they're all just functions. The only thing that's different between them is how they're parsed. And so glyphs that are modifiers will parse that, because even though the language runs right to left, the parsing is left to right. And so if it sees a modifier like, say, reduce, whatever the next glyph is will be interpreted not as something to be called immediately, but as something to be called within the modifier. So if you do /+, which is the same as, say, APL's +/, that plus, rather than immediately operating on its arguments to the right as it normally would, will be part of the reduction. You cannot define your own, you can't name things and then have them be parsed as modifiers, because since the grammar is context free. And so what that means is that if you have your own thing that wants like a higher order function, something that's going to take a function as an argument, you have to wrap whatever your function is, whatever the code of your function is, in parentheses. So that it won't be called. So parentheses, rather than being a grouping construct, as it is in most languages, because you don't need to group anything ever, parentheses lets you define inline functions. And so if I do say +1, 2, that adds 1 and 2. But if I do parentheses, surround the plus in parentheses, now I've just got a 2 on the stack, a 1 on the stack, and a plus on the stack.
Yeah, so I think this answers something I was wondering about when you mentioned that when you do assignment, it'll turn it into a function only if it's taking arguments from the stack.
Yes.
I was wondering, how do I make a function that takes no arguments but still does some computation when it's called? And sounds like parentheses are the answer there.
Yes.
Yeah, this is very cool. So it's, we might have lost a couple listeners. Don't worry, we'll skip. I've got a new line of questions and topic conversation in a couple minutes. But this is it's very cool. It would be the equivalent of in one of J, APL, or BQN, kind of having just like a reduced set of combinator glyphs, whatever they call them. And so in this case, we kind of have not just B. So like other than J, because J uses S as the to train, but in APL, at least, dialog APL and BQN, they use the B combinator as the to train. Because of the fact that this is a concatenative or stack language, you actually get B, B1, B2, B3, basically what is B underscore N, because the juxtaposition of any two functions, regardless of arity, just means you're going to call those in sequence. So if you pass, a function that takes 3 arguments, that's going to be the equivalent, and then a unary after that. That is, I think they call that the Bacard or the bunting. They only go up to, B is bluebird, B1 is blackbird.
There's only so many birds.
Yeah, and then they ran out of, I think, birds that start with B. But yeah, Bacard and bunting, I think, are like B2 and B3. You get that all for free. And then you have flip, which is the C combinator. You've got dupe, which is the W combinator. And then you've also got, I think the other one you call duplicate, which is the one that duplicates.
Well, there's dupe, there's flip, and there's over.
Oh, over was the one that.
Over is a name taken from like stack languages.
Right.
Where it copies the second value to the top. I don't know if there's a normal combinator name for that.
Yeah, I'd have to look. That one is it's a little bit different. But with that sort of that small set, you can then spell the other ones, which is kind of similar. I think in dialog APL, they don't have the equivalent of the back hook or what is called, left in BQN, but you can spell it with, a combination of, the W combinator and I can't remember, it's the D combinator. Anyways, it's just it's very like, I don't know, at least for me, it's like a fun intellectual exercise, like understanding what you've done in Uiua. And yeah, I'm definitely going to highlight it. And at some point, I'd like to give a talk that's like, the different ways that you can spell combinators in different languages. And like stack languages, I don't really think get mentioned that much. And now I have the perfect language. I don't actually have to leave array language land. I can just go to Uiua and then poof, I've got my stack language. And yeah,
and it might seem weird to like, I don't know, maybe the listener, whoever, like, why do you need all this stuff? And the answer is because Uiua does not have named local variables. So you cannot give names to things that are not global. Not even like alpha and omega or in BQN like the script X, script W. And so at one point I did have like defund style, but basically you could type special letters in and it would correspond to, say, if you typed A, it'd be the first argument, B would be the second argument. And I just didn't like how that made the code look. I didn't like doing that. And so I took that out. And so now everything is just fully tacit. And what I'm trying to explore with the language, I think, is because you guys have talked about tacit code a lot and how when it gets too big, it just gets unwieldy and complicated. And so what I'm trying to explore with the language is how to make it not that way. I want these kind of like data flow type operations, and actually, and in fact, all code in my language to just to be that way, to be this like pure, beautiful construct. That's my goal. How much I reach that as the language currently is, I don't know. You can look at some of the expressions and you're like, what's going on here? But I don't know. Some of the other modifiers I've added address some of the more complicated things you would have to make.
Yeah, that's awesome. I mean, I for a long time have thought it's a kind of a shame that this space isn't explored. Like the different ways to implement or to call combinators, like the stack languages provide one kind of avenue, array languages provide another avenue. The fact that the fixed arity versus ambivalence, like that affects your design choices. But like in languages like Python, C++, Java, like having parentheses, like kind of just, you can't really do much in that space. And that is like 90% of the languages. And I've even looked for papers in like academia that, explore the different ways to, invoke functions and combine functions. It doesn't really exist that I can find. I mean, Haskell is another, functional language is another space. And they do odd things because most of their combinators are implemented via operators where you define a precedence. That's a part of like defining an operator is like you choose the precedence between 0 and 9. But function application.
I did basically the same thing in Singeli, although you can choose any number.
Oh, really? And well, it's the thing in Haskell. 10 is always function application. So there's no way that you can define a operator that has higher precedence than function application, which is also like a design choice. Like you don't necessarily need to have that. And I think in BQN, it's quite interesting that you have the ability with like the underscores of like defining your 1 and 2 modifiers, and that like affects. Anyways, it's just it's a very interesting space, and it's awesome that you are, you've created this cool language and are exploring that. And I hope the same way that ArrayCast inspired you, or at least partly inspired you to go and create Uiua, maybe someone's listening to this conversation now and thinking, wow, if Kai did it, I can do it too. And we're going to have all these cool languages, competing in, some arena in the future, like, I don't know, there's some Pokemon or Digimon show.
There doesn't have to be only one winner, though. I must point that out. I mean, that's a big deal. It's great to, be able to go in all these different directions. And maybe you say, well, this feature is great. This feature is great. They don't go into the same language, but we have 2 different languages and you can choose one or the other.
And I think it's awesome too, that your language, like I don't know an array language. I guess maybe Niao counts. But most array languages, including BQN that get created that are based on sort of APL and J inherit the ambivalence. Every operator has both a monadic and dyadic definition. And that I think is like it's a huge choice that affects the language and potentially can make it a lot harder to learn, a lot harder to read. And yeah.
Wait, what with Q? Doesn't Q not do that? Or try to not do, or encourage not doing that? I'm never really sure.
Q is just K, right?
No, not in this respect, I think.
No?
Isn't it that Q replaces all the monadic forms of the symbols with words instead? And therefore they are separate.
I guess that's true. I mean, every word built-in function has fixed arity. Now that I'm jogging through all the different
So this is also true in, I think, most Ks at least. It's still trying to give you the ambivalent syntax over it all. So what happens is that you have the syntax that's resolved when it's parsed, and then after parsing, everything has only, and there's some weird caveats to this, but as far as I understand, everything has only one valence after it's parsed. But I mean, it's trying to fit into this model of you have, your infix and your prefix functions. And so, I mean, basically the APL design. And I mean, Q might be kind of different from that.
Yeah. I think it's just, it's interesting though to see a language that doesn't adopt that because, who knows, maybe that makes it way easier to learn and like.
Yeah. Well, so if I can comment on one thing that I was just thinking about this episode. One really interesting thing about the stack paradigm, which you've used for the combinators, is that every operation that you have can, of course, take multiple arguments, but also return multiple arguments. So that's what the flip does. It takes two, returns two. And I was thinking that, like, even one thing that I brought up on the ArrayCast is that actually, instead of having scan and fold be separate, one really nice combination is that you can take the function and your list of things to scan, and what you return is both a scan, an exclusive scan, and a fold. So you get the two things together. And I mean those together, like if you want an inclusive scan, then you shift the exclusive scan over and you add the fold element to it. So that's a shift function. But for a lot of other things, like if you're using it for array strides or something, that's just kind of the natural form. You want both of those together. And another common example that people probably know is the division and modulus. For a whole lot of algorithms, you want to calculate division and modulus at the same time. And in APL, you have to do two different functions. I mean, I guess there's a thing that you can use with encode and dialog, but it's not that nice. So yeah, just a comment is one interesting thing to explore would be, array functions that return two things and see if there are other constructs that allow you to do more natural array programming that way.
Yeah, there's only one other than those like flip, and I guess over technically takes like two arguments and returns three, right? And sort of like roll and unroll, do 3 and 3.
Yeah, I mean, but those are just stack manipulation. They're all kind of the same.
Yeah, but the only one that actually I think returns 2 is gen, and gen is not it doesn't have a glyph. It's you type gen and that's it, and that generates a random number based on a seed. But that it pushes the random number, but it also pushes the next seed that you can feed to the next call of gen. That's the only one I have that returns two things other than the stack functions, I think. There actually is a little bit of ambivalence in some of the functions. So in particular with the modifiers. So some of the modifiers, not very many, but a couple of them do something slightly different depending on whether the function you give them takes one or two arguments. So the ones I'm mainly thinking of are group and partition. And so group was inspired by BQN's group. And then I looked at the APL BQN dictionary for, how do I do the partition in BQN? And it's this long thing of how do you like group things by sequential keys. And so I just added a partition one too. But both of these basically, they'll in one way or another split your array into segments based on something. So by group, it's by grouping things by an index, and partition, it's by sequential sequences in another array. It doesn't really matter, but basically, if you pass group or partition a dyadic function, it acts like a reduce. But if you pass it a monadic function, it acts like an each, or like a rows, or a cells, something that builds up a new array, basically. And that's what I've settled on for now. I don't know how much I like that, but it makes it more flexible, and it makes it you not have to nest quite as often.
Interesting.
I was going to bring up, it's kind of funny we haven't talked about it. The one thing that I am proud of for the language is the audio and the images.
Oh, yeah.
I could talk about that a little bit.
Yeah, absolutely.
So built into the online interpreter, and then you can also do it in the native interpreter. You can create image data if you make, say, an array of pixels. They can either just be grayscale, or they can be RGB or RGBA. If you make an array of this data, you can it can, on the web interpreter, it'll just show you the image of what that data represents. And so you can do something similar with audio, where if you make an array of the audio samples, it'll just give you a little player that plays that audio for you. And it's cool because you can do these math operations to generate waves and things, and you can compose them in different ways to create cool images or audio or whatever you want.
And how does it decide again whether or not my data represents sound or images?
Yeah, so on the web interpreter, just because it's trying to present the language to you, it just does a check like, oh, does it make sense to convert this to audio data? And is it above a certain size? Oh, then it's audio, and otherwise it's images. Well, if it doesn't look like image data, then do it in image. If not, then it just does a normal array. On the native interpreter, if you're actually just trying to run it on your machine, you have to explicitly call functions to do that. So there's like an audio play function, an image show, an image encode, so you can save it to a file, things like that.
Yeah, it's very cool. I think it's similar to what was it John Ernest did with
I remember that one. Yeah, he did it with K, right?
Yeah, his implementation of K, and had some similar kind of web IED built into his version. You could very quickly get some sort of graphic stuff, which makes it like very, very fun to play with. Yeah, you are now the second kind of language that does that, and yeah, it's definitely fun to play around with it on the web IDE.
Yeah, one cool thing I also added, and it doesn't work on web. I don't know how I would make it work on the web, but on native, I have another function called audio stream, which basically you give it a function, and this function takes in an array of times, and you return an array of samples. And it calls that function over and over again with progressing times, and it will just play audio forever. And what's also cool is that in further invocations of the interpreter, it keeps the time that you're on. And so you could almost, what I'm going for is kind of almost like a digital audio workstation, is that you can modify these functions, and then as you save that, it picks up the music right where you were, or picks up the sound right where you were. And continues playing with your modifications.
Yeah, it's super neat. One of the questions too, I know we're past the hour mark, so I'm not sure how much time we have to chat about this, is the fact that you've implemented this in Rust.
Yeah.
And I'm curious, because you said you've always been interested in implementing interpreters. So like if it was a number of years ago that you were doing that, have you always been doing this stuff in Rust, or were you doing it in other languages, and sort of what was the path to Rust, and how have you found implementing a language in Rust, and would you recommend it to other folks out there?
Yeah, when I first started like working professionally, I was working with C++, and this was about a couple of years after I think Rust hit stable, and I started using that. And the company I was at, I had a lot of freedom to kind of work with what I wanted to, so I started using Rust. And ever since then, I've used Rust whenever I could for projects. I just like the fact that it's fast. I can make an interpreter as fast as like a C interpreter could be, theoretically, but also the type system a lot helps me with a lot of stuff, and then the macros. So especially for something like array interpreter code is like notoriously macro heavy, from what I understand.
Yeah.
And so the Uiua interpreter uses a combination of macros and traits, which are like Haskell, like type classes in Haskell. And it uses these together to make it so that your functions can be implemented on every type of array. But yeah, so I mean, professionally, I program in Rust and also some C#, but it's kind of my go-to language for most things.
Interesting, yeah. It's very cool that there's now I think actually I have seen a Rust BQN VM, I think, implementation, or the start of some implementation.
Yeah, that was never finished. We do have like a binding so if you want to run BQN in Rust, what you have is just a binding to CBQN that calls into the C interpreter. So that's kind of the preferred way now, which puts a damper on, anybody wanting to do something for Rust embedding.
Yeah, writing an array language interpreter is an interesting exercise, especially with a lot of the algorithms you have to write. I think some of the hardest ones for me were like Windows or multi-dimensional Windows is complicated, and by extension, multi-dimensional find.
Yeah.
I think I don't know if that's what it's called in BQN. The one where it like puts ones wherever it finds instances of your array in another. And then I don't know, things like take can be, or multidimensional
Take
take.
is like astonishingly hard for what it does.
Yeah.
No, like just taking one dimensional take is simple, right? But as soon as you get multiple dimensions in there, it gets complicated.
That's the thing for folks out there that want to implement a little array interpreter. Like, honestly, it's very similar to a stack language as well. Like, if you just stick to scalars and rank one, vectors, it's really, honestly, pretty straightforward, especially if you're coming from a language with a decent either, library ecosystem or standard library. Like, a lot of the operations in APL just map to algorithms in C++. So if you're not worried about efficiency, you can just naively call those, do a bunch of copies all over the place, and you're good to go. But as soon as you skip up to those higher dimensions, it can be, I don't know how many interpreters I've written where I just sort of stopped at, rank one for most operations. I did a couple other products and stuff, but then never have I implemented the higher ranks for an glyph like take or something like that, because it just hurts my brain.
Yeah, what's weird about it is it's a very different way than you normally write code, because normally the dimensionality of the code you write, so you just write a couple loops that go over this dimension or these items or whatever. But when you're writing the looping array code, looping over items in dimensions, and you have to also be looping over the dimensions and things, and it gets really complicated really quick.
Yeah, it is. I remember looking at April, which is implemented in Common Lisp, if I recall, and the implementations there it's very interesting because a lot of them are just super, super simple. And then you look at, the most complicated functions, and yeah, I think I recall take, but there are some pretty elegant, you'd think, oh, this is pretty complicated, but then, I'm not a Scheme or Lisp programmer, but that code is pretty nice and pretty easy to read. All right. I feel like we're past the hour mark. I do have one last question, but I feel like also I've been asking a lot of the questions. Are there questions from other folks about Uiua? No. All right. Well, I'll take the last one then, which is, we'll leave links for folks to check it out. But how much buzz has this? Have you posted this on the Hacker Newses or the Reddits?
I have not. I think Marshall actually pointed it out in the Discord that no, I have not posted this in a single place. This is actually the first public discussion of it.
Really? How did you and Marshall end up crossing paths? Did you ask him a question? Or?
We didn't. I don't know. Marshall, how did you find it?
I'm not entirely certain. Either you followed me on GitHub and then I checked your profile, or I did some search for BQN and ran into it.
That makes sense. Yeah, so it is public on GitHub. The best resource for information on the language is uiua.org, uiua.org. So it's got a full interpreter, and it's got tutorials, language tour, and all the tutorials have the built-in interpreter embedded inside them, which I think is a cool way to present it. It's mostly inspired by BQN's website. So it's all public. It's mostly at a point where I'm happy with people seeing it and giving input, because I would like feedback on actually using it for things. Because the most code I've written, or the biggest program I've written, is an HTTP server, like a very basic one. I specifically made it good enough to serve the website itself. But I would like feedback on on whatever, honestly.
I'm not sure. Hacker News is a dangerous. So is Reddit. Is it dangerous? It is. They're kind of like the dumpster fire corners of the internet that you got to, if you did not grow, if you were, I can't remember, born after certain, but certain people I've talked to, they'll post something and then they're on YouTube and oh my God, people are so mean. I was like, don't you know what YouTube comment sections are? You can't take that stuff seriously.
I think our programming language would be pretty kind. That's probably where I'll start.
There are nice places, but I would be interested to. I think something like this would. I'm biased though, so I obviously would click the upvote button. But I would be interested to see. If BQN gets a certain amount of traction in APL, I'd be interested to see folks' thoughts and just get more people aware. And also too, if you are listening and you are also like Kai, who has a programming language that you have spent an immense amount of work on that is, totally usable. It's like way past the leak code stage, which I'm thinking already about making a YouTube video because, that's basically all I do on my channel is I just solve YouTube leak code problems. So if you've got a language you can solve a couple leak code problems, it's good enough for me. But if you were listening thinking, oh yeah, maybe I should plug my language, we would love to hear about your array languages if you're working on them. Because like I clicked on your website this morning and I was like, holy smokes, like this is a full blown thing. Like I had no idea that it was out there, which is why I was kind of asking, like, how did I miss this? And the answer is because you've never plugged it anywhere.
Yeah. Well, this is my official plug. Check it out.
All right. Well, unfortunately, I don't how many listeners do we have, Bob? Do we know? I don't.
Any given episode usually gets around 800 to 1,000 downloads.
We're not at the million listener.
We're not at the million listener yet.
All right.
It's all right. The listeners of this podcast are my target audience. So.
Well, and if they want to get back in touch with us, of course, contact at ArrayCast.com. And we can forward any questions or comments back onto Kai, although I think if you go to uiua.org, there'll be ways to get in touch with him more directly. Super cool language, really interesting. One thing I noticed, you were talking about your pursuit of tacit, that you run into the same issues. As soon as you go left to right or right to left, when you want to do modifiers, suddenly you have to start using parentheses to group them. You just really can't get away from that, it seems, because the same thing with J is it's right to left, except for modifiers, which are left to right, because you've got a long left reach. And you have to do that just because that's the way you have to be able to separate them from the standard functions. Anyway, that's my little bit. Contact at ArrayCast.com, and this has been super cool. And you have done a lot of work, and I was really impressed with how advanced the site is and how far you can take it. Just for a language starting out, it's quite remarkable, and it does remind me of BQN as well.
Thanks a lot, Bob.
Yeah, this conversation has been. This is awesome. Like I've been so entertained getting to ask you questions, and I'm excited for our listeners to hear, and I'm sure they'll have some exciting thoughts to share, and hopefully they'll go check it out. And maybe in the future we can have you back and get some Uiua updates. And it is a very
that'd be great. I'm also on the APL Farm Discord. If anyone wants to just
awesome. Is there a Uiua channel?
No, I think the index error was where I was talking about a little bit.
I would just use the main one.
Okay.
All right. Yeah. So if you want to reach Kai as well, APL Farm, we'll have a link in the show notes for that Discord. And yeah, would love to have you back in the future and chat again. I feel like we probably could. I mean, I definitely could have asked, probably an hour more worth of questions, but we gotta dice these up a little bit. Otherwise, our listeners are gonna be like, "What is going on? A 4-hour podcast?" Although there are other podcasts that have 3 to 4 hour conversations, but that's not us. So, anyways, thank you.
I'm not editing those podcasts.
Yeah, maybe at some point in the next few years we'll get some LLM editor, that we can save Bob a lot of work and have that stuff automated. But we're not there yet. So we thank Bob for all his hard work and doing all the heavy lifting, and also as well, Sanjay and Igor are hardworking transcribers.
The transcription team, Sanjay and Igor, yes, they do a great job.
They fix what the LLMs can't do.
Exactly.
Yeah. we still need humans are still important for the moment. Anyways, thanks so much for coming on, Kai. This has been awesome, and yeah,
it's been great.
Looking forward to talking to you again in the future and seeing where Uiua goes. So with that, we will say happy array programming.
Happy array programming.